Hi everyone, how are you today? I'm teacher Saraswati from IPG campus, Pulau Pinang. Today, we are going to learn topic 13 of Form 2 Mathematics, which is simple probability. Are you ready? I'm sure you are. Let's start right away. Let us look at our learning objectives for today's lesson. By the end of today's lesson, you should be able to first, describe the complement of an event in words and by using set notations. Second, determine the probability of the complement of an event. And finally, solve problems involving the probability of an event. Now, let's look at these posters. Whenever you are having difficulties, do you remember people around you being positive and telling you that things will improve or change for the better? What is the chance that it will occur? Look at three different events as in the diagram above. What are the likelihood of these events to occur? Can you predict them? Many events can't be predicted with total certainty. The best we can say is how likely they are to happen. In real-life situations, you will always ask yourself, how likely is something going to happen? Or, what are the chances of an event happening? And the likelihood or chances can be measured by using simple probability. Now, what is exactly the meaning of probability? It is also the likelihood of something happening in the future. Probability is the measurement of possible occurrence of an event expressed either in the form of fractions, decimals, or percentages. In our daily life situations, many events cannot be predicted with total certainty. But we can predict only the chance of an event to occur, whether it is certain, more likely, less likely, equally likely, or impossible to happen. Let's learn the probability terms used in this topic. First, certain. An event will definitely happen. For example, New Year will be celebrated on the 1st January of each year. The celebration is indeed an event that will definitely happen each year. Second, more likely. An event will probably happen. For example, it will be more likely to flood during the monsoon season in East Coast states. Third, equally happen. Two events that have the same chance of occurring, like tossing a coin with equal chances of obtaining head or tail. Fourth, less likely. An event that will probably not happen. For example, for student A to be elected as a representative of his or her class. Fifth, impossible. Events that cannot happen. For example, for the traffic light to turn blue. It is an event that will not happen as there are only red, yellow, and green light. Next, we will learn the probability line. The chance that something will happen can be shown on a number line. We can also use numbers to show the probability of something happening, which is between 0 to 1. The value of probability can be written in fractions, percentages, and decimals. Also, if an event is certain to happen, then the probability of the event is 1 or 100%. And if an event will never happen, then the probability of the event is 0 or 0%. The probability formula defines the likelihood of the happening of an event. It is the ratio of possible outcomes to the total possible outcomes. This can be written in equation as probability of an event A to occur is the number of possible outcomes of A divided by the total number of possible outcomes. Also can be written as this. Let us discuss some questions to understand this better. Question 1. A bag contains a few blue and red marbles. If you are to pick a marble randomly, what is the probability of picking a red marble? We must first determine the event for this question. From the given information, event A will be picking a red marble. The number of red marbles will be 7, and the total number of marbles in the bag is 12. By substituting into the formula of probability, we will get probability as 7 over 12. Question 2. You are given a spinster with blue and green color. What is the probability of the arrow landing on green? We must first determine the event for this question. From the given information, event A will be an arrow landing on green. The number of green will be 4, and the total number on the spinster is 10. By substituting into the formula, we will get the probability as 4 over 10 and simplified to 2 over 5. Next, we are going to learn about complementary events. Before we start our lesson, we need to understand what exactly a complementary event is. How do we understand it? From the previous examples, we can define those two events are said to be complementary when one event occurs if and only if the other does not. Take this for an example. If we are talking about an event, the complement of that would be something that is not the event. Now, let me show you what I am talking about using some examples. If an event is considered as a boy, then the complement of the event, a boy, is not a boy, or in this case, it's a girl. Of course, there are only two genders. If it's not a boy, then it should be a girl. So, the complement of the event, a boy, is a girl. Now, let us look at another example, which is a success. If it's not a success, then we say it a failure. So a failure would be the complementary event of success. Or you can even say not success. The next event is rainy day. What do you think is the complementary event of rainy day? The complementary event is not a rainy day. why don't we say sunny? Can anyone think of that? Yes, you are correct. If it is not a rainy day, it can be any other type of weather, like cloudy, or stormy, or even windy. So sunny is not the only complementary event of rainy. Because of this, we say not a rainy day is the complementary event. The next event is black. So, the complement of this is not black. Why is it not black? It is because we have so many other colors that we can choose other than black. So the complement of black is not black. When you toss a coin for the event head, the complement would be tail. This is simple and can also be answered without a knot. Next, the complementary of cold is hot, and for sing is float. So, do you understand the idea of complementary events with these examples? Question 3. What is the complementary event of rolling a 5 on a die? So here, for complementary events, we must take everything except 5 itself. There are two ways of answering this question. First, by words, or second, by set notation. Just to recall, in a set notation, we will write a complementary event of A as A prime. So, to answer question 3, we can say the complementary events of rolling a 5 on a die is 1, 2, 3, 4, and 6. Or, when the element of event A is 5, then the complementary events of A are 1, 2, 3, 4, and 6. Now, question 4. Write the complementary event of winning a tennis match. Again, to answer this, we need to state the event, which is winning a tennis match. Then, the complementary event should be not winning a tennis match. When the elements of event A is winning a tennis match, then the complement of event A is not winning a tennis match. Question 5. First, let us look at the Venn diagram. There are elements, and inside the circle, there are number 1, 2, 5, 8, 11, and 13. Outside of the circle, but within the box, there are number 4, 7, and 12. Now the question. Write the complementary of event A. From the diagram, we can say that the complementary of event A is 4, 7, and 12. Or, when the element of event A is 1, 2, 5, 8, 11, and 13, then the complement of event A is 4, 7, and 12. That is simple, isn't it? Now, try this on your own. Question 6. Write the complementary event of going for a vacation on weekends. Alright, are you done? Let's check together. The answer for complementary event is not going for a vacation on weekends. Well done, everyone. So, from the previous examples, we can deduce that the complement of an event completes that particular event. From this, we can also say that the sum of probability of an event and probability of a complement of that event equals to 1. Thus, from this equation, we can determine the probability of complement of event A is equal to 1 minus probability of event A. Now, let us complete some questions for your understanding. Question 7. A die is rolled. Find the probability of getting number 3. To answer this, we must determine the event and the sample space. From the question, we can say that the event is getting number 3 and the sample space is 1, 2, 3, 4, 5, and 6. So, the probability of getting number 3 is 1 over 6. Next, we are going to look for the probability of not getting number 3. The event of not getting number 3 is 1, 2, 4, 5, and 6. The probability of not getting number 3 is 5 over 6. Can you see the relationship between the probability of an event and its complement? Yes, 1 over 6 plus 5 over 6 is equal to 1. Can you write down the equation relating both probabilities of an event and the probability of its complement? Yes, we can deduce the equation, which is the sum of probability of an event and its complements equals to 1. Question 8. The Venn diagram shows the elements in a universal set. Calculate the probability of A prime. To answer this, we must write the event and the sample space. From the Venn diagram, we can say the sample space is 1, 2, 3, 4, and 5. Event A is 1, 2, and 3. So the number of elements in sample space is 5. And the number of elements of event A is 3. The complement of event A is the elements other than 1, 2, and 3, which is 4 and 5. Meaning the number of elements of A prime is 2. Since there are 2 elements in the complement of event A and divided by 5 elements in sample space, hence the probability of A prime is 2 over 5. Question 9. Let us try this together. A number wheel is rotated. Find the probability of getting even numbers and the probability of getting not even numbers. Let us check the answer together. Again, we must determine the event and the sample space. From the wheel, we can see the even numbers are 2, 4, 6, 8, and 10. so the number of elements is 5. The sample space is the number 1 until 10, so the number of elements is 10. The probability of getting even numbers is 5 over 10, or can be simplified as 1 over 2. Next is the probability of not an even number. From this, again, we are looking at the complement of the even numbers. To find the probability of not even numbers, we can have 1 minus 1 over 2 equals to 1 over 2. Another way is to use the elements of not even numbers. Congratulations to those who got it correct. What about the rest? Let us try another question. Question 10. The Venn diagram shows the elements in a universal set. Calculate the probability of B prime. Let us take some time to answer this question. Alright, come, let's check the answer together. The sample space for this Venn diagram is badminton, tennis, golf, soccer, and softball. Event B is golf and soccer. So the complement of event B, other than golf and soccer, are badminton, tennis, and softball. So, the answer to the probability of getting the complement of event B is 3 over 5. Well done, everyone. Let's move to the next subtopic, which is solving problems related to simple probability. Let's start with question 11. A set of letters that form the word probability were inserted into a box. A letter is picked out from the box randomly. Find the probability of getting a consonant. Remember, whenever you are given a question, make sure you write down the event and the sample space. For this question, the sample space is P, R, O, B, A, B, I, L, I, T, and Y. The event consonant that we label as C is P, R, B, B, L, T, and Y. How are we going to find the probability? Yes, very good. We will divide the number of elements in event C to the number of elements in the sample space. So the answer will be 7 elements in C divided by 11 elements in the sample space. And finally, we have 7 over 11. That is simple, right? Next, find the probability of the complement of getting a consonant. Again, you must recall back what you have learned a while ago. We know that the probability of complement would be 1 minus the probability of a particular event. To answer this, we can take 1 minus 7 over 11, and the answer would be 4 over 11. Question 12. A jar contains several marbles with 20 red, 10 green, 15 blue, and the rest white. A marble is picked out from the box randomly. The probability of picking a blue marble is 1 over 4. Find the probability of choosing a marble which is not blue. Not blue refers to the complement of an event of picking a blue marble. So, the probability would be 1 minus 1 over 4, which equals to 3 over 4. Simple, isn't it? Now let's find the number of white marbles in the jar. First, we need to write down the information given, which is the probability of picking a blue marble is 1 over 4. By using the relation between probability and the number of elements in event blue marble, we can write 1 over 4 equals to the number of blue marbles, which is 15, divided by the number of elements in sample space. And the sample space would be 20 plus 10 plus 15 and plus the number of white marbles, which we write as W. Now, after calculating, we will get 45 plus W equals to 60. By subtracting 45 on your right, the total number of white marbles would be 15 marbles. Now, let's conclude our lesson for today. The complement of event A in a sample space consists of all outcomes that are not the outcome of A or A prime. We can say that sum of probability of an event and probability of a complement of that event equals to 1. Also, the probability of complement of event A is equal to 1 minus probability of event A. Thank you, and I hope you enjoyed today's lesson. Till we meet again. Goodbye.